Hey guys, I'm gonna try and do a couple of these problems that are like, I just selected some from the incredibly long worksheet I gave you, from which you will not be doing every one, but you will be doing some. So this is just a little sample. I think I chose 9 questions. So if I was gonna do this one, all right, very important. Arc sine is exactly, it means the exact same thing as inverse sine. They have, like, this is just 2 different ways to write the same thing. It means literally the same thing. And I kind of liked that one book that I got problems from did it this way, one did it the other way, so you guys see both. They both are used. So people are like, why don't we just use one? Well, because not everybody's on board with that. If I say arc sine of theta and I say inverse sine of theta, it means the same thing. So don't let that throw you off. It just means sine inverse, okay? So if I say the arc sine of negative root 3 over 2 equals theta, that means that the sine of theta is negative root 3 over 2. And I would jump to my unit circle and I would find the place, well, place is technically, right? Where the y coordinate is negative root 3 over 2. So here at 5 pi over 3 and here at 4 pi over 3. So 4 pi over 3 and 5 pi over 3, but remember, for arc sine, it's got to be from negative 90 to 90 or negative pi over 2 to pi over 2. Somewhere in that range, just keep brackets. So I can't use this one or this one really, but technically 5 pi over 3, I could do like this, right? I could say this is my angle. So instead of saying 4 pi over 3, which is, I can't do that between negative 90 and 90, I can do this one. That's negative pi over 3. So no, and like not really, but really this one is negative pi over 3. And this is my answer. So trick is rewrite. We'll do it again here. Rewrite. Again, this is the inverse cosine. It means cosine theta is negative root 2 over 2. Go to the unit circle. And we see cosine is some x coordinates. So there's one there and there's one here. So I got 3 pi over 4 and 5 pi over 4. The rule for the range of the inverse cosine is it's 0 is less than theta is less than pi. So I can't use this one, but I can use this one. So this is the answer. So that's just kind of your basic there, right? You just switch from, you switch the angle and the ratio, and you switch it from inverse or arc sine to regular sine, and then you use the unit circle to answer the question. So same deal. These ones are a little trickier. The arc cotangent, instead of the arc tangent, it's the arc cotangent. But this is basically the same thing as 1 over the inverse tangent. So you can say 1 over arc tan of negative root 3. And so this is one where it's like, you guys have trouble because you're like, root 3 is not on the unit circle. Well, I agree. But instead of thinking about it that way, why don't we think about it like, is there a way to rewrite the square root of negative root 3? Like, can we write it as a fraction? We write it as a fraction, yes. And then we look for these things on the unit circle, and we're not quite there yet, but we're almost there. And it's really negative root 3 over 2 over 1/2. And again, this equals theta. So I'm saying the cotangent of theta should be, I don't know why I'm putting that in parentheses now. Should be negative root 3 over 2 over 1/2. So I look for a place. Again, the cotangent is like x over y, because we know that the tangent is like y over x. The cotangent must be the opposite. So I'm looking for an x of root 3 over 2 and a y of 1/2. but I want them to be opposite sides because that's going to make this whole thing negative. So x is √3/2 and y is 1/2, but opposite signs is going to be here and here. And so I got to pick either 5π/6 or 11π/6. But I can't choose either one of these because it has to be between -π/2 and π/2. So 5π/6 is like way outside my realm. It's got to be somewhere here, right? So this is the guy that I pick. But I can't call him 11π/6. I got to call it -π/6. I'll do one more and then I'll break this and I'll do the last ones after this. So arcsecant of -√2. So this one has the same kind of a trick to it. Where you got to like rewrite this so that it's like a meaningful fraction that y'all can look at on the unit circle. You can call this, well, let's just rewrite it as a secant, and then it's gonna be easier if we think about the cosine. So, use this arcsecant equals this. That means that the secant of theta equals -√2, which means that the cosine of theta is equal to -1/√2. And this, again, you're looking for x values now, and there's no x value that looks like this on the unit circle. But that's because the values on the unit circle have been rationalized. So if I rationalize this fraction, I get the cosine of theta is equal to -√2/2. That I know is on there. I know it happens twice. X's are negative, so I want this one and this one. And so I'm like, it's either 3π/4 or 5π/4. And I'm pretty sure in the instructions, it reminds you that the range of the arcsecant is from 0 to pi, not counting π/2. You can't count π/2 in this one because the sign is 0, so you get 1/0. But it means I can't use this one, right? I got to use the one that's somewhere in this range, and it's 3π/4. So this equals 3π/4. That's how you do that. So there's a lot of like, I think sometimes it's easier to like switch these things right away and then think about these functions. Sometimes it's a little easier. Again, with the tangents, there are two that are hard, that are tricky because you have to like rewrite it with this weird fraction trick. √3 is one of them and 1/√3 is the other one. So like if you see one of these, this is sometimes written as √3/3. So you got to be a little careful if it looks like that. But those are the only two that are particularly tricky, I think, for the tangents. So keep an eye out for those. I'll do the next 5 problems on here in a minute. Again, the numbers are the ones from your the textbook, so you can just find them there. Okay, bye.